Hi guys. So as I was looking through your rehearsal exams, we did really well, and I'm really proud of you guys. But I noticed that one area that we were struggling was rearranging equations and then doing a unit analysis of that. So I wanted to take a moment and do an example problem, maybe two. But let's start with this one. Like if we have this equation, and I have all my list of knowns, and I'm asked to solve for the acceleration. Well, the first thing I should do is I should rearrange this equation to solve for acceleration. So recognize acceleration is multiplied by 2 and the delta x, or x final minus x initial, and then we're added to the velocity initial. So since this component is not multiplied or in a radical with acceleration. There's not one here, but I just experienced as I was looking at your work that you're not used to getting rid of anything. Like if there was a square root and there was something outside of the square root, you'd want to move that first. So this is added here. So we need to get it to the other side, and we'll do that by subtracting. So we'll have velocity final squared minus velocity initial squared equals 2 multiplied by acceleration, delta x. Okay. Most common mistakes, students automatically multiply or divide. So if it's an addition, if this is added, then we subtract it to the other side, even if it's our first step. And now we want to get acceleration by itself, so I can divide by 2 delta x. I can do that to both sides. So we have velocity final squared minus velocity initial squared divided by 2 delta x, and that will give me acceleration. So I rearranged the equation. Reminder, delta means final minus initial, so even there we could change that to a delta, but we have velocity final squared minus velocity initial squared divided by 2 x final minus x initial, right? That's going to be acceleration. Let's do a unit analysis. Recognizing accelerations, they're in meters per second squared. So that's what we want our final unit to be. We want all that to equal meters per second squared. We're going to take velocity final, which is meters per second, but it's squared, right? Minus velocity initial, which is meters per second squared, divided by 2 is unitless, so we're not worried about it when we're doing a unit analysis. So x final, which is meters, minus x initial, which is meters. So reminder, if units are added or subtracted, we just end with the final unit. Like meters minus meters just gives us a final unit of meters. Or same here, this velocity squared, we have meters per second squared minus meters per second squared, so we just would end with meters per second squared. Okay. Since this is divided or multiplied, but in this case divided, we can distribute that too. So I could change that to meters squared per second squared, and now I'm dividing by meters. Dividing by meters would be the same as multiplying by the reciprocal. So this meters would cancel with one of those, and I'm left with meters per second squared. So that is the unit I was wanting to end with. That's a great check to see if I rearrange this equation correctly. Now that I've done my units, I can do a numerical analysis, which is simply plugging in the numbers. Going velocity final is 30 meters per second squared minus initial, velocity initial was 0.5 meters per second squared, divide that by 2, multiplied by x final minus initial, which is just 0. Be careful when running this in your calculator. If you're going to do this all at once, you need to recognize this is the top and this is the bottom, right? I have to tell my calculator. Again, you could chunk these calculations, but if you're going to do it all at once. Okay, all of that is on the top of my fraction. I'm going to divide that by 2 multiplied by 310 minus 0, or 310. 1.45121. Okay, now what about significant figures? Well, I have this multifunction, multiplication, subtraction, division, all that, right? So I'm going to go with the least amount of sig figs. Infinite number of sig figs, 3 sig figs, 3 sig figs, 4 sig figs. So my least amount was 3 sig figs. So I will round this to 1.45, and my final units were meters per second squared. Okay, so when approaching these kinds of problems, start by rearranging your equation to solve for the unknown. Then identify what units do I want to end with. Do a unit analysis. Do you in fact end with those desired units? And once that has verified that you rearranged the equation correctly, then run the numbers, and then you'll get your final answer.